Hi, I welcome you to another session of ray optics. And in today's class, we are going to discuss about the dispersion of light and the combination of prisms. So let us start with the basic idea of the definition of dispersion. What do you mean by dispersion of light? It is a process of splitting up of white light into component colors in a medium. The process of splitting up of white light into component colors in a medium is called dispersion of light. Now the question, what is the cause of dispersion? Let me tell you, the cause of dispersion is the variation of refractive index. Variation of refractive index with wavelength in a medium. The cause of dispersion is the variation of refractive index with wavelength in a medium, which is provided by what is called Cauchy's relation. That is actually given by what is called the Cauchy's relation. Cauchy's relation. Cauchy's relation. According to Cauchy's relation, the wavelength refractive index as a function of the wavelength of light is given by A plus B divided by lambda square plus C divided by lambda raised to 4. In this formula, the terms like A, B and C are constants. The terms A, B and C are constants in such a way that A is much greater than B and which is much greater than C, which implies approximately Cauchy's relation n of lambda is given by A plus B divided by lambda square approximately, because the third term being very small, its contribution to the refractive index will be negligible. Now the question, which element of the visible light has the maximum wavelength? It is red. Red has the maximum wavelength, so I can say the refractive index of red will be less than a refractive index of violet, because maximum wavelength in the visible spectrum corresponds to red and minimum wavelength corresponds to violet. So now we have to say that the refractive index of red is less than refractive index of violet, which means in a medium, that means when white light enters into a medium, I have to say that red travels faster than violet, because refractive index n is equal to C divided by V in a medium. Lesser the refractive index means greater the speed. So in a medium, red travels faster than violet. Now, in the last class, we have learned about the deviation produced delta is equal to n minus 1 into A. Right? For a small angled prism, approximately that relation is valid here as well. Which implies the deviation, it depends on the refractive index n, because angle of the prism is a constant, right? There is no change going to arise here. So which implies what? Which implies deviation produced for violet will be greater than deviation produced for red. As you can see from this figure, this is white light. White light is incident on a prism, and inside the medium it disperses into red color and violet color. And you can see that, so with respect to the normal, the one which undergoes maximum deviation here is violet. So deviation is given by this angle. So violet experience more deviation compared to red. The question, why violet undergoes more deviation? Because the speed of violet is less than speed of red. And again, both has to reach here simultaneously as well. So when I have lesser velocity and if I need to reach simultaneously, means I have to look for a path which is the shortest, and that is what violet does here. So violet travels in a shorter path and red travels in a longer path. So finally you can see that both reaches here simultaneously, right? So which means violet deviates the most. So that means here the deviation is greater for violet and it is least for red. In VIBGYOR, so VIBGYOR, deviation decreases in this order. In the case of VIBGYOR, deviation decreases in that order. So deviation will be greatest for violet, then for indigo, then for blue, then for green, then for yellow, then for orange, and it is least for red. So it decreases in this direction. So it is maximum for violet and it is minimum for red. Now what I am going to discuss is, so this is a very important relation, let me tell you. So I am going to discuss about what is called angular dispersion. Angular dispersion, theta is the difference in the deviations of violet and red. Now using this relation I can say this is NV minus 1 into A minus, what is the deviation for red? It is NR minus 1 into A. So which means what? So theta I am going to get is equal to, so NV into A minus A minus NR into A plus A, right? Minus of minus becomes plus. So this will give you theta is equal to NV into A. This minus A, this plus A cancel each other, right? Minus A and plus A, this will cancel out. Which means you have got NV into A minus NR into A. So I can take A as a common factor here. So I have to say the angular dispersion theta is equal to NV minus NR into A. NV minus NR into A is the expression for angular dispersion. Now we are going to discuss about the dispersive power of a prism. Dispersive power. So dispersive power omega is given by the ratio of angular dispersion. It is the ratio of the angular dispersion to the mean deviation. The angular dispersion divided by mean deviation is what is called the dispersive power omega, which may be written as theta divided by delta. But what is theta? Theta is NV minus NR into A divided by mean deviation is N minus 1 into A. What is N? N is the mean refractive index. So A and A will be cancelled again. So I can finally say omega is equal to NV minus NR divided by N minus 1. So omega is equal to NV minus NR divided by N minus 1. And more importantly, you have to understand that omega is a dimensionless quantity. Omega has no dimension. So this is the expression for dispersive power. So I will write again here. So omega is equal to NV minus NR divided by N minus 1. What is N? N is mean refractive index. Which is approximately equal to NV plus NR by 2, or that is also is approximately equal to the refractive index of yellow. So in these respects also you will be getting the answer for what? The dispersive power. So from these two discussions, the important formula you need to understand is theta is equal to NV minus NR into A. Then omega is equal to NV minus NR divided by N minus 1, where N is the mean refractive index of the white light, which may be given by us by the formula NV plus NR by 2, or approximately the refractive index of yellow color. Now we will study about the combination of prisms. The prisms can be arranged to form two types of combinations. The first combination being written here, where that is dispersion without deviation. What do you mean by dispersion without deviation? So in this case, white light is incident on this prism, on the first prism. So it will divide into violet and red colors, and this will emerge parallel to the incident ray. The emergent ray is parallel to the incident ray, which means the total deviation delta net is equals delta 1 plus delta 2 is equal to 0. Because it is coming out parallel to the incident ray, so total angle of deviation is equal to 0 here. Total angle of deviation is equal to 0, but theta net is equals theta 1 plus theta 2, that is not equal to 0. There is a net dispersion, but the net deviation is equal to 0. From the first relation, you can see that delta 1 is equal to minus delta 2. That is what you can see from the figure. The prisms are inverted with respect to each other. The two prisms are inverted with respect to each other. That is the reason for this minus. So here I will say N1 minus 1 into A1, right? This is the relation we know. N1 minus 1 into A1 is equal to minus of N2 minus 1 into A2. The important relation we need is this one. The prisms are arranged in such a way that N1 minus 1 into A1 is equal to minus of N2 minus 1 into A2. What is the need of this minus? What is the purpose of this minus? The purpose of the minus is to prove that the second prism is inverted with respect to the first prism. The second prism is inverted with respect to the first prism. So this is the relation which we can use in order to study about what? In order to study about the dispersion without deviation. Now we will discuss the next case. This is deviation without dispersion. Deviation without dispersion. Okay, yes. Deviation without dispersion. What is the case here? As you can see here, what is entered here is white light, and what is emerging is also white light. In this case, you can see that the emergent ray and the incident ray are not parallel to each other. Which means, this case, delta net not equal to 0, but theta net is equal to 0. That is, theta 1 plus theta 2 is equal to 0. Or I can say theta 1 is equal to minus theta 2. Theta 1 is equal to theta minus theta 2. This combination is otherwise called achromatic combination of prisms. Achromatic combination. This combination is also called achromatic combination of prisms. So theta 1 is equal to minus theta 2. So I will write this theta 1 as N1V minus N1R into A1 is equal to minus of N2V minus N2R, right, into A2. So this relation will let you know the unknown variable here I have to say. what or unknown variable comes into play, I have to say this relation will clearly give you the picture of the same. Okay, just writing it properly. Minus of n2v minus n2. Okay. So knowing other variables, the unknown variable can be determined using this relation. So this is called a achromatic combination of lenses. Achromatic, which means no color. So what comes out is white. What entered here is white light. What comes out here is also white light. So this is what is regarding the combination of prisms.